Okay, this is the answer to the week 8 quizzes. This is the first quiz, and the answers are, of course, over here on the right, using these letters. And you can pause this video to check all the answers that you've got. Now, for week 8, class 16, there was a couple parts to the quiz. This is the first one. Um, Clearly show the steps taken to determine what percent of the total rocket mass must be propellant if the rocket's going to go from low Earth orbit to low lunar orbit. Assume the rocket exhaust velocity is 4.1 kilometers per second. Well, we might remember from the Tsiolkovsky's equation that the two velocities, of course, are the delta V we need to get to and the exhaust velocity. So we've got the exhaust velocity. We just need the first step is to find out the delta V we need to get to. And that comes from this column right here. And we can see that the low Earth orbit to low lunar orbit looks like 4.1, and I think that's kilometers per second. Yeah, kilometers per second also. So we can see that the exhaust velocity and the delta V we need are equal. And so if we go back to our Tsiolkovsky's equation, we see that these two numbers are equal. And so that's going to give us 1 minus e to the minus 1. And we know that e to the minus 1 equals 1 over e, right? Because the minus sign just reverses when you put this expression in the denominator. So if you don't have a calculator, and you won't for your exam, your in-class exam, so you have to use this chart. So we go over here to the chart, and for delta V over VE of 1, we come up here and see that the mass ratio is going to be about 3, just around 3. I did this incorrectly in class. I think I called that 6. It's not. The mass ratio is going to be just about 3, and actually, it's exactly equal to E. About 2.72 is the actual value of E, but you could use 3 here. So, and the mass ratio is m0 over m1. So if the mass ratio is 3, then 1 over that will be 1/3. So, and that's of course going to be equal to this expression, which is the inverse of the mass ratio. So 1 minus 1/3 is 2/3, or 67% of the fuel, of the mass of the rocket must be fuel. So that's how you would do this first problem. And again, to use this chart, you need to find the mass ratio first. So the number over here, the inverse of that is what will go as this second expression. So if the number over here is E, then you would put 1 over E over here, or 1 over 2.72, and you'll get about 65% of the mass must be fuel. Okay, the second problem that we had, let's see, the second problem was, if I can find it here, yeah. Do you remember when the solution breaks down? Yeah, we did this in class. We had this matrix inversion solution. I don't expect you to be able to invert the matrix. I just want you to see how it works. But this solution breaks down when the two lines. I haven't shown the second line. The second line would be a2x plus b2y equals c2. That equation is shown here at the second in the matrix. That's not shown here. But when those lines are parallel, there's not going to be any solution, and you will not be able to take this inverse. Now the way to see that is to remember how do you get the slope of this line. And I don't know how you learned slopes and lines in high school, but basically it was, I remember it was y equals mx plus b. It was how I learned it. And y equals mx plus b, the m was the slope. So if we solve for a y here, then we'll get the slope will be minus a1 over b1. Minus a1 over b1 will be the slope, and that will be the angle that this makes with the horizontal axis. That will be the slope. So notice that if the second equation, which would be minus a2 over b2, if that's the same number, then the slope of the second line and the slope of the first line will be equal, and you will not be able to solve this equation. The inverse for this will break down, right? And that's usually comes from what's called the condition number for this, and we'll see what the condition number maps into for GPS satellites in the next class. All right. So you can generalize this to 3 lines. If there's 3 lines, then they will intersect in a point, and that solution will break down when 2 or 3 of the lines have the same slope. Right? And you can generalize to 4 lines, 5 lines, 6 lines. You can't see them, you can't imagine them anymore, or draw them. But yeah, you can only imagine that they would be intersecting at a point. But the key thing is that they are not parallel. When these lines are parallel, the solution breaks down, and this inverse will become you will not be able to take this inverse. Even with the computer solution will break down or give you a nonsense number. So, do you remember when the solution breaks down? It breaks down when these lines are parallel, or when the slope of the line is equal, and the slopes of the line are equal when A1 and B1 have the same relationship as A2 and B2. When these coefficients have the same linear relationship, the lines have the same slope. In other words, minus A1 over B1 equals minus A2 over B2. And when that happens, the solution will break down. And that's it. Good luck with your quiz.